Hi there. Welcome to ARC338, how Goldman Sachs minimizes the impact of managing events. I'm Brian Carlson. I'm the Operational Excellence Lead for the Well-Architected Program. I'm going to talk to you a little bit today about Operational Excellence, the Well-Architected Program. And Goldman Sachs is going to talk to you about how they take the best practices and principles from Well-Architected and they make their lives easier. I'm pleased to be welcoming to the stage later Aline Hardwick, who's a vice president at Goldman Sachs, and Sujoy Saha, who's one of their engineers. And we're going to be talking about event management. All right, so first, a little roadmap about where we're going today. I'm going to give you a little introduction, obviously. Then we're going to talk about some operational challenges. They'll probably resonate with the problems that you have in your own environments. And hopefully you'll be able to see paths forward that can help you address those issues. We're going to be talking about automating operational excellence, which is both a design principle and a best practice. After that, there'll be some conversations about some case studies that will directly illustrate successful mechanisms for managing events. And then finally, we'll wrap it up with some thoughts. All right, so starting from there, what is well-architected? Well, well-architected is a lot of things. It's a framework. It's a set of design principles, pillars, best practices. It's a lot of content that is guidance that we've built. Now, a framework is one of those situations where you take what you like from it and you adopt it, and you get value from it. Not everything's required, but it's a lot of best practices about making cloud-native architectures. So we have our content, which is extremely useful. We also have the tool in the console that helps you perform a review of your own workloads so that you can go through this review and address where you are with your best practices adoption. If there are issues, it will identify them for you and make recommendations on corrective actions you could take. There's also a ton of educational material in there that's all contextualized. So there's lots of links through to deeper content. So it's a great learning tool, as well as a way to track changes to your system over time. You can record milestones in your personal data that you completely control. So whatever you save inside of there is there for you. All right. Now with that, let's talk a little bit more about it. There are 5 pillars of well-architected. The first one is operational excellence, and I'm quite proud of that as the operational excellence lead. However, that doesn't mean it's the most important one. It's just the first, and the reason it's the first is it sets up the conversation for how you're going to approach all of the other pillars. The first question inside of OE, Ops 1, is possibly the most important question inside of well-architected. It's what are your priorities, and how do you determine those? Because those priorities drive how you evaluate security, how you evaluate reliability, how you evaluate performance efficiency, and cost optimization, the other 4 pillars of well-architected. All right, so if your foundation is solid, if you have these things in place, you're going to have an effective workload. All right, so OE, what is it specifically? I like describing any organization as a 3-legged stool. Everyone in an organization is there to support the line of business, the product, the company. And then the other 2 legs of the stool are operations and development. Development is there to achieve the business outcomes. Operations is there to support the business outcomes. We're trying to elevate our organizations by stepping up on that stool and raising ourselves up, supported by those organizations. Now, it's possible to elevate yourself if you only have 2 legs on the stool, but it's quite the balancing act. It's possible to do it if you only have 1 leg on that stool, and that's a heck of a balancing act. So the emphasis here is when all parts of your organization are working together, you're far more effective. And we're trying to achieve those business outcomes. And I want to point out one of the last things on here. We're emphasizing continuous improvement. We don't want to be satisfied with where we are because the efficiencies we make in our operations have a very long tail. Ideally, the amount of time your application spends in production is far longer than time spent in development. So everything you do inside of operational excellence is going to support you, reduce your costs, and make your life easier for a long time. All right, so we have design principles. These are things we want you to emphasize when you're thinking about what you're doing. These do change over time. That is, we swap them out as we want to make a different emphasis. The first one is to perform operations as code. When you do this, we take human error and we reduce it significantly. We also can ensure a consistent execution of a process. And beyond that, we can treat it just like code. If we have codified procedures, we can version it. We can keep it in a repository. We have all the powerful engineering wrapped around that. Refining our operations procedures frequently. If you recognize something is wrong and there's a way you can fix it, If you have the time, fix it. Emphasize that. Refine them frequently. If we discover that we're always doing this wrong, or there's a way to reduce it in the number of steps, we can reduce that operational toil, then do so. Anticipate failure. Now what are we talking about here is both recognizing sources of failure, so that ideally they can be removed, but also recognizing when failures are possible and being able to respond to them more effectively. Now, it's perfectly reasonable to have problems like a memory leak and leave it in production because there's value from the application, knowing that your way you're coping with that is that you reboot the server periodically. So that's okay. All right, and then learn from all operational failures. And this goes back to refine your operations procedures frequently. If something goes wrong, fix it. Now, everyone makes mistakes. Everything breaks always. Werner Vogel will tell you that as well. Everything fails always. And it's okay for that to happen. But if it happens 3 times in a row, people are going to look at you a little bit differently, right? They're going to evaluate you a little bit more critically. So, learn from those operational failures. And where we're going right here is we want you to design with ops in mind. Because when you do, that long tail of value is right there for you. All right, so today is going to be a lot of conversation around OpsCenter. It allows you to aggregate your operational issues into a central point to deal with them. It allows you to diagnose and remediate them, bringing additional data in. And when you look at them, we can sort of walk through and see there's a whole lot of best practices that are all surrounding it. In fact, there's a bunch of design principles too. In fact, right now, it is literally covered with best practices and design principles. All right, so there's a lot going on there, and a lot of benefits can be had, so that ultimately, between Systems Manager and OpsCenter, you can achieve operational excellence. Now with that, I would like to welcome Elaine to the stage. Thank you.
Okay, can everyone hear me? So as Brian mentioned, my name's Elaine Hardwick, and I work for Goldman Sachs as a software engineer along with Sujoy. And I just wanted to kind of give you a little bit of overview about Goldman Sachs. So we're actually celebrating our 150th birthday this year, which is really exciting. But when you think of something that's 150 years old, you may not think of something that's new and innovative and exciting, right? However, Goldman Sachs is really focused on innovation and learning new things and trying to help all of its employees learn and foster in our businesses as well, right? The other thing to note here is that we have over 33,000 global employees, and over a third of those are engineers. So those engineers are focusing on that innovation and allowing our businesses to really achieve success and learn and experiment and grow. So let's talk about some of the use cases that we have with the public cloud. So this is an area that we've felt is innovative for a long time, and we've focused a lot. So our first area was our compute extension. We had an internal compute farm, which did a lot of our internal compute provisioning and management. And what we did instead was we started to look at AWS for managing our liquidity and our capacity. We then looked into lift and shift models, so any areas where our customers needed to be closer to their data centers that had an isolated number of dependencies or not a lot of dependencies on the firm systems, we started looking there. We've also focused on new innovation. So like what I said, with over 11,000 engineers, a lot of us are really antsy to get our hands on the latest and greatest technologies. So we have sandboxes, which is a best practice from OE, I've understood. And so every engineer can request a sandbox and play in that environment and identify new tool sets. The other area with innovation that we've looked into is experimenting in a lot of our businesses. So especially in our consumer lending space, we're starting to migrate a lot of those workloads into AWS. And the last area that we've really focused on is that business continuity and resiliency. So we have, as a financial services industry, we're severely regulated. We deal with auditors a lot, and one of the areas with our investment research portal was that if anything went down on our firm-wide side, we needed to be able to spin it up quickly and efficiently so external users could handle that. And so one way that we did that was allowing that to be publicly accessible in the public cloud if we needed that for disaster recovery purposes. So one other thing to note about Goldman Sachs is we have 14 key business principles, and these are all really important to each of us as employees and really do define us as a culture at Goldman. So number 11 is one that we think really relates to this topic today, and I'm going to read it. We constantly strive to anticipate the rapidly changing needs of our clients and to develop new services to meet those needs. We know that the world of finance will not stand still and that complacency can only lead to extinction. So as we're continuing to migrate more and more of our workload into the public cloud space in this ever-changing environment, we really have to focus on those processes and procedures. We know that without focusing on that, we're not going to achieve success, and we can't have that strong operational excellence that we know is required for our firm and for our clients. So now that we've kind of given you a little bit of background about Goldman, let's talk about some of those operational challenges that people will face when they're dealing with achieving that operational excellence. So I'm sure several of you have probably seen an email familiar with this if you've worked in AWS. You've had yeah, you can raise your hand if you want. There's a degraded hardware that's associated with your EC2 instance. What are you going to do when you see this email? Especially as a level 1 support person, how do you track it? How do you know what to do? How do you know where to go and how to identify it? Which teams to reach out to for escalations? How do you learn from this, right? If this keeps happening in the same account with the same issues, where do you go from there? So this is our operation event system that you might see. Like we said, you get an event that occurs. You may see this email, you may see a CloudWatch alert. There's a lot of different ways here. You're going to enter this manually, possibly into some kind of system tracker. Once a developer or support person can be assigned to that, then they're going to go in and they're going to either work in the console, right? They're going to be manually making some changes, or they're going to do an automated script or an SSM document if they're a little bit more advanced. That hopefully will resolve the issue. And then the last thing that's outstanding is there any kind of post-mortem that's done to address the issue, right? So that you can learn from it and grow from it and continue to reduce these incidents from happening. So a couple of these really big issues when you're dealing with a process like the one that we just saw in that previous slide is that you're monitoring operations across multiple accounts in multiple regions. Not all of these accounts are going to be using the exact same services. It's not going to be a standardized environment, so your level 1 support is really going to have to understand those environments and how those can affect the incidents that are occurring. It's also difficult to look across all of these at one place, right, and have to jump into each and every account. And at Goldman, we have thousands of accounts, so it gets very confusing. Manual interventions can also be extremely overwhelming. So when you get all of these events that are coming in and these incidents that are occurring, how do you handle that? How do you know, as that level 1 support person, how to solve that issue quickly and efficiently, and how do you make sure that you're doing the right thing in order to solve this? Those escalation paths may not be clearly defined, right? You may not know who actually owns that resource. If that Lambda function went down, who is in charge of that? How do you actually reach out to them and figure out what's going on? And then resolution operations are not codified. So kind of what we talked about previously, if someone's just going into the console and manually making a change or doing arbitrary script, you may not be able to re-vet what's going on or make sure that it's following similar processes that you would like when you're dealing with code, right? And the last thing, so this is our operations excellence micro account model. So this is how we would like to address some of these issues. The first thing is we wanted to aggregate all of our operation items centrally. So we store all of our operations events into one centralized account so that we don't have to go to those various accounts and figure out all of the incidents. We have it all in one place. The next thing is once you get all of those in a consistent fashion in one account, you can start mining for which things are happening more frequently. And the ability to do that allows you to automate things that are more critical and that are occurring more quickly and streamline that process. The last thing is that now that you've identified which things you can automate, you also know which ones you can't automate as easily. And so with those, you need to understand who actually owns the environment, who owns that resource, and how can you escalate if something isn't resolvable in an automated fashion. Now with these principles, Goldman also has a few additional ones. As we've mentioned previously, we're heavily regulated, right? We're dealing with auditors all the time. So we have to be able to pull up an incident, understand what happened throughout that entire life cycle of that incident, and be able to prove to the auditors that these were the steps that were taken, these were what happened, and this is how we resolved that. And then also, we're looking at things over time, right? So we want to make sure that we're trending down on all of these incidents from occurring, we're learning from our previous mistakes, and that we're growing in our process. So with that, I'm going to hand it over to Sujoy to talk to you about how we actually implemented achieving this.
Thank you, Elaine. Okay, so in order to meet the various audit and compliance requirements, as well as achieve operation excellence at the same time, we went about a process by which we would automate our entire event response model. So let's take a quick look at that real quick. So the biggest problem that we have that's there in the standard operation event management system that you would see like in different firms is that you have to have some process by which you collect information and events that are happening in different accounts, and then like in a time-bound fashion, make sure to put them in a in central location. You can work off of that. The challenge there, however, is that oftentimes we'll see that not enough information is either captured or recorded properly in the tracking system. So that makes it really hard for support staff to take action on that, as well as from a compliance and audit perspective, it doesn't have all the details necessary to convey the information that of the severity of the event. The next bit is if you have specific automation scripts that you run in response to these events, oftentimes you won't see them in Jira. Someone will say that, okay, I ran my automation script to fix this, but they won't say what they did or have a link to that script about okay, this is what they ran to fix that thing. And then if they're fairly advanced, they'll have okay, I ran this specific automation doc, but then that automation doc might be very unique for that use case and might not be as repeatable or as reusable as we would like it to be. Finally, after the incident has been successfully resolved, in a lot of cases, we won't actually see that the event is, at least in the Jira perspective, it's not updated to reflect that, or there might not be enough details on it to say, okay, it was properly remediated, as well as if there's any lessons learned or that kind of thing. So to solve the first challenge of event aggregation, we created a central event aggregator. For that, we used several different cloud native services and integrated that with Amazon EventBridge. EventBridge is a service that we use to collect information from various different resources, one of them being AWS CloudTrail, which captures all the different API calls that are being made in every account. And we streamline that and downstream that to EventBridge using specified rules for specific operations that we have interest in. For example, in this specific one, we look at an event that was done by a specific API call, and then we'll see, okay, this is a specific event that we're interested in, we'll capture that. Next bit is for different applications and Lambda functions, we will use Amazon X-Ray to collect various error states as well as different trace IDs and other information that can be used for for example, if we run into a weird error state where the Lambda function is not running because of some access denied exception, we can have specific automations flying off of responding to that and sending out alerts saying that, hey, you need to update your IAM instance profile to fix this thing. And then finally, we've got Amazon CloudWatch. This service already has existing services such as CloudWatch alarms that are configured for resource outages or other event-based or time-based specific CloudWatch events that you configure when certain resources either go down or some action happens. So in either of those use cases, you want to we wanted to capture whatever events that are available from existing Amazon accounts and then streamline that into EventBridge. So that way, we don't have to maintain different collectors or agents in different accounts. We can already streamline and capture all the stuff that they already have in their own accounts. Finally, we capture all of these events and make them available on EventBridge, and then this allows us to have an event-driven architecture for responding to these events as they are arriving in the standard event bus for this service. Now, for every event that arrives, we actually have a process by which inspects each individual event. We do this through what we call the Taskmaster Lambda function, and its job is, as its name, right? Like it basically looks at an event, it figures out what task it needs to run in response to that, and then it tags that event with that specific automation. So it'll parse that event and incident. It'll see, okay, this is the event from this specific resource. Then it'll basically analyze, okay, what's its source, what are the dependent resources, and what are what's the category of this event? Is it like a production level? Is the resource affected by this event a production event? Is it a production resource, or is it like a non-production resource? Based on that, it'll assign criticality. And then after that, what it'll do is it'll basically parse the event and create a new, and enrich a new ops item, which will have all the information necessary to diagnose that event and then respond to that for either through an automated system or through manual intervention at a later stage. And this is where we use ops items, which are like standard entities in OpsCenter that we use for tracking each individual event that happens. And this actually lets us track every single aspect of that event and allows us to confirm it to its life cycle. Now, we also tag this ops item with relevant escalation info. The reason we do that is because for whatever reason, if you're not able to take the further downstream action on that, we can actually make sure that appropriate teams are notified on that and they can take action. And then finally, we also determine which remediation workflow to use, and we tag that to the specific ops item. Now, what is in this ops item that represents the event? So whenever an event occurs, our taskmaster Lambda will create this ops item. This is supposed to represent the entire details of the event as well as its life cycle, right? So we wanted to capture as much information as possible. So one of the first things we capture is the root source of that event. What is the event associated with? Is it the instance that went down? If it's so, we'll say that, okay, it's a compute resource. Or was it a database that had some issue? So we'll capture that. And we'll find out what are different identifying information for that. This will include the Amazon resource number of that resource, as well as the account and the region where this resource is affected. The next thing that we'll collect is the enhanced operation data. What this means is we'll capture information relevant to the instance operations. This will be the what's the instance, what's the IAM role that the resource takes or assumes into to perform its daily job. So we'll capture that. We'll also look for where are the logs and other X-ray traces located for this resource. In addition to that, if a resource is an instance or EC2 instance, or if it's a RDS which has backups or some concept of backups, we'll capture we'll tag information such as where is the latest snapshot IDs for that, so that if we have to do a restoration or recovery operation, we can do so. And finally, if it's an application or Lambda function, we will capture information about where is the S3 object or bucket that has the zip archive for that specific binary function, or so of that binary executable, or some other zip archive for the Lambda. So we'll capture that so that we can use that to redeploy the function if necessary. In addition to that, we'll also make sure that we are downstreaming all the different tags that are available on the resource itself. In this particularly, we wanted to highlight that we wanted to capture the team and business unit specific tags. This way, we can make sure that we can identify who's owning the resource, and then subsequent follow-ups can be done by those. And then in addition to that, if the resource is non-production or production, we can actually set up alerts and priorities based on that, and we can tag the ops item accordingly. Finally, this also allows us to get the escalation path, and we can actually capture that either from the resource tags itself or from the account owner information for in which the event has taken place. Let's take a quick look at the EC2 degradation event that Elaine mentioned earlier in the presentation. So for that specific event, we'll create a ops item which will have the following information. So first of all, it'll have the instance ID of the resource impacted by the degradation event. It'll have the account number and the region. The next would be the IAM role of the instance profile, and it'll have a list of all the EBS volume snapshot IDs that were captured for that instance while it was in operation. And it was maintaining, it was passing all health checks and stuff. Finally, we'll also capture all the tags on that resource, including the business unit that owns that resource, as well as any, if it's production, non-production, and other escalation information as they are available. Now, once we have this enriched Opsitem with all these details, we wanted to have some process that could respond to that the moment this event is created. Because the moment this is there, it means that an event has occurred, and we have to take some tangible action against that. So for this, we have an OpsMonitor Lambda. Its sole job is to basically look for these ops items to be created, and then basically execute an SSM document or Systems Manager document in response to that. In case of our previous example with EC2 degradation, we have a automation document that basically inspects the Opsitem details, and then correspondingly it'll try to restore that instance from its EBS volume snapshots and perform checkouts that yes, it has successfully been redeployed. If not, it'll send out alerts for manual intervention. Now, in addition to like us using this separate process to trigger automation documents through the OpsMonitor Lambda, we also are able to configure what are known as rate controls for SSM. So what this does is it allows us to have some configuration in how we execute these specific automations. The first thing that we do is we can configure like how often these automations can run, or like what are the number of parallel executions it can do by setting a concurrency metric on that. The second thing that we can do, and you can see an example over here, is that we can create like branching workflows based on how many errors and other things that we encounter while running this automation. For example, if our EC2 degradation event occurred and then we ran our automation and the automation failed for whatever reason, we see that, okay, like for a given number of times, like it's experiencing high levels of failure, we'll actually send out alerts to the specific business unit to like, okay, like we'll send an alert out for like manual intervention, and they can step in and then try to do a manual restoration operation. If not, like we'll continue running our automation, and then once it's successfully restored the event and all the checks have been completed on that, we will successfully close the ops item out, and that will indicate that the event has been resolved and without any intervention whatsoever. Now let's take a quick look at what the alert would look like for this if automation failed. So in terms of alerting, like most of the times we alert people based on like what are the different kinds of, I would say, like automation failures that you encounter. If, for example, automation has failed most of the time and you're seeing that it's never working, and for whatever reason, because of some environment change or some resource change, your automation suddenly does not work anymore. In cases like that, that's a critical alert. We want to notify like business units or the support staff to step in and make sure that the best automation is in place. So we'll send as many like notifications, we'll send notifications to as many notification platforms that are there. There are a vast majority of them in GS, so like every business unit has their own. So we try to send them to as many as possible. Then after that, like for escalation and awareness, we'll contact different levels of support, like who maintain that resource. And additionally, we'll keep tracking that through the ops item, as mentioned earlier. Now, in cases of some of the lower level alerts, we'll classify these based on like how many, like what's the error metric based on like the automation execution. The high-level alert is something where we constantly see like failures above a certain threshold that's set, and in those cases, we'll just like send out alerts to like some like one or two notification platforms and like just a few levels of support, so that they're aware that they need to come back and fix this at some point. Now, for the lowest level, like these are mostly for transient errors. We'll sometimes see that whenever like there are issues of increased API error rates in Amazon. So we'll just like we'll have that available on SNS topics for teams to consume if they want to do anything with it at a later stage. Now, what happens when a team receives a critical level alert? At this point of time, like they have to write or update the automation that's there to take care of this event. Or if if automation doesn't exist for this specific event, they'll have to draft one, right? So for that, like we have a very clear-cut process. DevOps engineers will basically like write up new SSM documents, or scripts to respond to different events. And that'll go through standard like firm SDLC. This includes scanning and like peer review. Once it goes to peer review and has been published to into the AWS cloud ecosystem, it'll be available either as a SSM doc or like it'll be available as a SSM doc. And here, like DevOps engineers can like log in either through console or through like some script invocation. They can execute that SSM document against the specific event that has occurred. And if that event is successful, then they will tag that automation as such that yes, this automation is successful, and now we can go forward with that. And now, once this automation is successful, they can actually tag it for use by the OpsMonitor Lambda function. And going forward from the next stage, whenever a similar incident occurs, and instead of like manual intervention, the OpsMonitor Lambda function will pick that up and like execute that automation because it's already been approved for use, and then this will over time reduce the number of like manual intervention steps you have to do for that specific event. And yeah, going forward, like basically we'll just tag that for use and associate that with the specific automation going forward. So that way, like over time, like whenever the same incident happens again, people will have to, like there'll be less manual interaction, and you can continue to edit and modify your script so that it can fit a wider variety of use cases, and over time, that'll simplify this interaction. Now finally, let's look at like what our automated events response system looks like. This is from what we discussed. The first thing is we collect events from different sources using EventBridge. And after that, like the Taskmaster Lambda evaluates those events, creates ops items for each individual event. After that, our OpsMonitor Lambda function inspects each ops item, creates and runs associated automation documents. It'll associate the automation document with that specific ops item to indicate that for this specific event, this automation document was run to indicate what was the event and what was the follow-up response for that. And finally, once that automation is successfully run, we will close out the event, and that will indicate that the event has been successfully remediated. Now, if something goes wrong with the automation, like we'll send out alerts with different levels of criticality based on what kind of error state the automation ran into, and we'll notify affected parties. Now, let's take a look at a few case studies and a few examples on how we did the end-to-end workflow where we use the end-to-end workflow that we just described for some very pressing use cases. One of them was Lambda deployments. So in the past, whenever we uploaded Lambda functions to AWS, we always had to do some like checkouts manually to see, okay, is this running properly? We would inspect the SNS topics or the CloudWatch dashboards to see whether or not it's maintaining a healthy state over time. However, this proved to be very tedious because developers would have to spend cycles like evaluating it and seeing, okay, if everything's right in a given environment. But we figured that if we could just reuse our existing system to basically check whenever a Lambda function is updated and then run certain post-deployment checkouts. So the specific event that we see in CloudTrail is this one. It's the update function code 2015 March 31st version 2, very unique, oddly specific. And we basically monitor whenever these events are there, and we will run it through our automated event response system. Now, Taskmaster will create an ops item for post-deployment checkout, and OpsMonitor will run the specific automation document that's specific to that Lambda function. Now if, for example, like imagine if this Lambda function is supposed to run on multiple resources and like assign tags or something, right? So we'll use the concurrency setting to do that, and then like we'll evaluate if through the error threshold setting whether or not it's successfully run. And based on like some error percentage that like our team will set, we will see like, okay, if error is less than like a certain percentage, like yes, it's successfully deployed, like keep executing the Lambda function as is and don't need to roll back. However, if we see that there's an increased error rate coming from that Lambda function and it exceeds a certain threshold, we will perform a rollback operation, and we'll do so by using the zip archive that we discussed in our ops item. We'll use that to re-upload the previous version of the Lambda function, and that'll ensure that there's complete continuity of the service, and we don't end up pushing out like bugs in our code, in our deployments. This will ensure that our service is resilient, and then our clients can have a high degree of confidence on our applications. So for the next use case, we've got EBS backups, and my colleague Elaine will talk about that and our overall backup strategy at GS.
Thanks. Okay, I'm back. So as Sujoy mentioned, we've got a bunch of different areas where we can reuse and re-leverage the exact same principles that he walked us through. So one is with this EBS backups. Before I get into that, I kind of want to give you a little bit of familiarity with AWS backup. I don't know if everyone has heard of it. Has anyone else used that service here? Cool, we got a couple. So we definitely use it. This is a service that AWS launched in early January of this year. And what it allows for us to do is basically store there's 4 different types of resources that you can store in a centralized backup vault. And one of the issues, since we have many distributed teams, sometimes groups may not understand all of the compliance standards that we need around backups. They may not understand the cost associated with different backups. They may not understand, I don't know, there's just a bunch of little nuances that you really have to think through when you're dealing with backups, and especially around the various different resource types. So AWS Backup really gives you a holistic view. It's allowing you to put all of those different resource types into one centralized backup vault so you can look at it holistically. It's also giving you the ability to create lifecycle policies and schedules and all that retention stuff. And it's really just improving your developer experience because they don't have to think about all of that. We've implemented an EBS backup module, so we've deployed this in all of our accounts, and it's a little different than the code here, but this is a sample code that you can look at. And what this does is it applies all of those cycle policies that we've mentioned. It's pushing all of the resources that are tagged to a centralized vault, and it's adding specific recovery point tags. So any tag that's on the resource that you're backing up will also get attributed, as well as additional tags that we're specifying in this backup module. And what that allows is for the developers just to simply do a tag on their resource, right? They don't have to think about all of this. It's very simple and easy for them to use. And then we get that entire holistic view and can really help drive things from a centralized fashion. So once we have all of these backups in that centralized backup vault, what happens when we really want to restore something, right? If something goes down, we want to follow that similar pattern that Sujoy had mentioned earlier, and we want to watch for that CloudWatch event that's going to kick off, create that Opsitem with the taskmaster Lambda, and then execute and restore the SSM. So what that SSM document is going to do is it's going to go into the AWS backup vault, and it's going to actually restore the item. So it's going to stop the instance because it knows what instance it is because of that Opsitem that's already been created. It's going to know which volume has been corrupted and detach that volume. And then it's going to reassociate the restored volume from the backup vault. And once it does all of those things, it's going to restart that instance, right? So no one has to touch any of this. It's really seamless and automatic. And if anything does go wrong, then that's where we can actually use the tags that were enriched on that Opsitem and escalate it to all the other individual users. Previously, teams would have to go in and they would figure out that there was an EBS volume that was degraded. They'd have to do all of those manual steps that I talked about originally, stop the instance, detach the volume, reattach it, go through that entire step. Nothing was in that centralized location, and it just was very tedious and took a lot of time. This is done really quickly and efficiently, and we can reuse it constantly, right? So if any other kind of resource goes down, we can use the same pattern and the same principles, which is really helpful. So with that, we kind of walked through these slides at the beginning of the deck, but I just want to kind of emphasize that we have already monitored operations across all of our multiple accounts and regions. We discussed that we have leveraged moving everything to that centralized operations account, and so we can see everything in a holistic fashion. We have made sure that all of our resolution operations are codified, so we can really go through and revet and reuse and follow those same SDLC patterns that we really like to do with our software development, and we want to use that in our infrastructure as well. We've made sure that everything's automated, right? We've looked at all of these events that are coming through. We've looked at the ones that are frequently happening or the ones that are critical, and we've automated those. And then anything that we can't automate, we're making sure that those are tagged with the appropriate owners so that we can escalate things quickly and efficiently. And we've also simplified that human intervention. There's really not a lot of steps that people have to take on. People can continue to contribute to this code base, and that we can really slim down the amount of human intervention and the amount of errors that occur because of that. So with that, I'm going to pass it over to Sujoy to wrap it up.
Okay, thank you.
Yep.
Right, so despite all the good benefits that we glean from this, there are a few challenges and future work that needs to happen to really take this to the next step. One of the first challenges we faced was the adoption of SSM documents as operations as code. One of the biggest things was that apart from learning all about new Amazon services and then keeping up to date with that, you also had to learn a new language, a new format to codify operations and then respond to those. The other bit was there was also some parsing issues with SSM documents in the beginning. You couldn't pass parameters to it, so you have to do some weird input transformations to make it work. However, I'm happy to report that with the launch of Project Falcon, a lot of these steps have been, a lot of these pain points have been remediated. Now you can actually execute Python scripts and incorporate that as part of your SSM document, and then you can have multiple steps executing based on different error controls and whatnot. You can set that up so that it can execute multiple Python functions rather than having a large YAML file that you need to additionally learn. In addition to that, one of the other ongoing challenges is by onboarding a process of operations as code. And the biggest challenge is for every new event or any event that has a chance of repeating, you'll have to craft and determine and craft I guess a new automation document to respond to that. And sometimes it gets challenging, especially because for a lot of these events, we want to restore that resource or take action very quickly. And we have to spend cycles to develop that. But it's an ongoing process, and we are making some progress there. Finally, for the last two things, we are seeing that OpsCenter has some service limits that can become pain points, especially for large deployments. One of this is that there's a limit on how many ops items that you can have in any given account in a given time. So this is, I believe the limit is 500,000, which is fine for there but then if you've got very large deployments in a given account, you can soon see the fact that we are creating so many, there are too many events in the account, we're creating a lot of ops items from that, and we might hit that limit, and that might cause us issues. So once again, these are some things we can work with the AWS team on, and then over time, we'll obviously see these limits get better. Finally, we also, apart from all the work that we've done with integrating all these ops items and all these events into OpsCenter, we also want to integrate this system with that of a GS incident management, either a GS Jira system or our own tracking system and other incident management systems that are there. That remains to be done. However, despite these challenges, I'm happy to report that we've achieved a lot of good things and got a lot of beneficial outcomes here. One of the first things I want to mention is that we've achieved operation excellence for deployed AWS resources. This includes Lambda function and EC2 for a certain set of accounts. We have achieved significant reduction in MTTR, in the mean time to respond, especially for Lambda function deployments, where we were spending a lot of cycles testing it out, evaluating it. And for EBS backups, we've achieved a lot, basically by automating the entire process, where people don't have to spend any cycles doing that tedious work. Now, in addition to that, our deployments now have greater confidence. As I mentioned, with our automatic rollback feature for application and Lambda functions, we are able to maintain high degree of confidence in our Lambdas. And that way, our clients don't have to worry about, okay, this new service is coming up, this new change is going to happen, it's going to break things. The likelihood of that has gone down quite significantly. And finally, for as I mentioned with the Lambda use case, we've achieved remediation and service recovery to quite a good extent for some of the use cases that we have. So again, we'll continue to make progress on these, and we'll be happy to share those details when the time comes. Thank you so much. I'm going to hand it back to Brian for closing remarks.
I don't quite remember what I was going to talk about here. All right, so there are a couple slides you're going to see a lot this week. You can always learn more. Well-Architected has the Well-Architected Labs, but AWS also has training and certification. So there's all kinds of avenues for education and for additional content, so please consider that. Well-Architectedlabs.com, I think. Well-Architectedlabs.com is where we keep our open source labs, so by all means check that out too. And thank you. I really appreciate you coming out.